Hello everyone. So in this video we're going to talk about differentiability implies continuity again, but now we're sort of just focusing on piecewise functions. So we did a similar thing in Unit 1 when we were talking about continuity, right? So I first introduced continuity, gave you the formal definition, and then we explored some things with limits and continuity with piecewise functions. So here I just wanted to mention, so I apologize for this typo here, so this should be 2.6, just so that makes more sense in your notes here. Okay, so here's the big question. How do we determine if a function is differentiable at a point with piecewise functions? So here I'm just saying that if the piecewise function switches from one piece to the other, at x equals a, then you will need to consider the left-hand and right-handed limits with the limit definition of the derivative to determine if the function is differentiable at a. Okay, so here I'm just noting to you that if the left-handed limit, the limit as x approaches a from the left of f of x minus f of a over x minus a, is equal to the right-handed limit, in other words, the limit as x approaches a from the right of f of x minus f of a over x minus a, then the limit overall, as we know, exists, right? The limit as x approaches a of f of x minus f of a over x minus a is equal to L. Okay. So the first thing we're going to do is just look at this piecewise function. And so I first want to, when I'm talking about figuring out if a function is differentiable at x equals some number, in this case x equals 3, I first want to just see and make sure that the function is in fact switching from one piece to another piece at that x value. And so we see that that's the case here, right? So we use the top piece for when x is less than or equal to 3, and then the bottom piece when x is greater than 3. So it is in fact switching at x equals 3. Okay, the next thing you want to do is just sort of figure out, is the function continuous at x equals 3? Okay, because if it's not continuous at x equals 3, then I can conclude that it's not differentiable at x equals 3, right? So there was those 3 ways where the function fails to be differentiable at a point. We said that the function, if the function is not continuous at a point, it's not differentiable. Right, so that's why I'm sort of breaking this process down into 2 parts here, where I first just ask you about continuity at 3, and then from there ask you about differentiability at 3. Okay, so the first step in figuring out if this is continuous, and this is why I just recalled this to you just in case we have forgotten. So here in step 1 it says we need to make sure that f is defined at x equals 3. So in other words, f of c must be a number. Right, so when I plug in my case here, when I plug in 3 into the function, I need to make sure I get out a number. So I should be using the top piece for f of 3, right, because of this sign less than or equal to, right? So where it has that bar under it for equals, I need to be using that. So I have that f of 3 is equal to 3 squared minus 1, which is 8. Okay, so I'm just going to put a check there just to show you that the function is defined at x equals 3, right? Because when I plugged in 3 into the function, I got out a number. Now I need to check if the limit as x approaches 3 exists. So since I'm switching at x equals 3, I need to consider the left-hand and right-handed limits. So from the left, I'm going to use the top function. So I get the limit as x approaches 3 from the left of x squared minus 1. And now plugging in 3 in for x, I get 3 squared minus 1, which is 8. Now I want to consider the limit as x approaches 3 from the right of the function, which means now I need to use the bottom function. And so now plugging in 3 here, I get that this is 7. Okay. So now looking at this, does the limit exist? And so hopefully we say no, right? Because the limit from the left does not equal the limit from the right, right? So since the limit as x approaches 3 from the left of g of x does not equal the limit as x approaches 3 from the right, then the limit as x approaches 3 of g of x does not exist. Thus, g is not continuous at x equals 3. Okay, and so since we know now from part A that g is not continuous at x equals 3, here I can just say no, since g is not continuous at x equals 3. Right, because in part B it's asking me, is g differentiable at x equals 3? And so that's what I was saying earlier, right, that we want to first check continuity, because if it's not continuous, then it's definitely not differentiable at that point. And so that's what happened here in practice.